Okay, you've got that big system design interview coming up. You know they're going to ask about modern development practices, especially, in a microservices world. How do you walk into that room and talk confidently about something like CI/CD pipelines?
Ugh, that feeling. Yeah.
Yeah.
You want to show you get it right. Not just the tools, but the real why behind building software well and quickly.
Exactly.
And that's precisely what we're here to tackle today.
Absolutely. We've sort of gathered all this knowledge, haven't we? Concepts, notes, real-world stuff, all about managing code, building it, testing it, getting it out there safely, especially when you've got, like, hundreds of microservices flying around.
Yeah, think of this deep dive as your personal prep session. I'll walk through the core ideas, like an engineer who's built this stuff and, well, sat in those interview chairs.
And I'll be right here with you, asking the questions, poking at the trade-offs. Maybe I'll even play the senior interviewer across the table sometimes, helping you figure out how to say this stuff clearly under pressure.
Perfect. So, our mission, let's unpack continuous integration, CI, continuous delivery, CD, and how to design pipelines that actually work. The goal is you can explain it all easily, get the nuances, and crucially, spot the bad ideas, the anti-patterns. That tells an interviewer you really understand.
Right. We'll hit the basics, then branching, which is huge pipeline structure, managing artifacts, super important, maybe the most important role. And yeah, wrap up with a little mock Q&A, put it all together.
Sounds good. Let's dive in.
So, okay, the terms. CI, CD, continuous deployment. At a senior level, they expect you know the basics, but they want to hear the difference, the relationship. How do you break that down quickly?
Right, yeah, don't just recite definitions. CI, continuous integration, that's the base layer. It's all about developers merging code frequently.
How frequently?
At least daily. Ideally, multiple times a day per developer, into a shared mainline, the trunk. And the CI server, it jumps in automatically, checks the commit, runs builds, runs tests, verifies it.
So it's not just pushing code, it's making sure it works with everyone else's code, like constantly.
Exactly, and the direct result of that verified integration, a build artifact. And here's like a massive interview point, a golden rule. You build this artifact once.
Once.
Just once. During that CI process, this single unchanging artifact is what might get deployed later.
Well, only once.
To stop things drifting apart, avoids inconsistencies. You test this specific artifact, you deploy this specific artifact. Simple as that.
Okay, build once, test it, deploy that thing. Makes sense. And where does this precious artifact live?
In an artifact repository. Think Artifactory Nexus, maybe a container registry, if it's Docker images. That's your single source of truth for version X of your software.
And don't forget, version control for your infrastructure code, too. Infrastructure is code.
Yeah.
Super important for making things reproducible.
Okay, so CI, frequent merges, auto-verify, fast feedback, single trusted artifact.
Oh, yeah.
But you mentioned earlier, just using Jenkins or Circle CI isn't the same as doing CI. How do you explain that difference? Yes. This is critical, shows real understanding. Lots of teams have the tools, right? Jenkins, Circle CI, Travis. But they might still only merge once a week, or have manual steps everywhere, or flaky tests.
So the tool's not enough.
Nope. It's necessary, sure, but it's the practice, the discipline, that actually is CI.
Is there like a quick check? A way to know if a team's really doing it?
Yeah, Jez Humble had these 3 great questions, good for your own check, and definitely smart things to bring up in an interview. 1, do you check into mainline at least once a day?
Tests the frequency, right?
Exactly. Avoids that big merge pain later. 2, do you have a solid suite of automated tests, especially behavioral tests, not just compile checks?
Right. Does it actually do what it's supposed to do?
Precisely. If you're just compiling, that's not really CI. It's like checking the car starts, but not if it, drives straight. And 3, this one's huge. When the build breaks, a red build is fixing it the absolute #1 priority for the whole team.
That feels really important. Why the huge panic over a red build?
Oh, because letting it stay red is just disastrous. It's a massive anti-pattern. Every minute it's broken, developers are either blocked, can't merge their own stuff.
Causing that delayed integration pain again.
Right. Or worse, they start checking code in on top of the broken build, trying to work around it.
Oh, God, that sounds like chaos.
Yeah, it's a chaos. I saw this team once. Build was red for days. People were tearing their hair out, merging against unstable code, commenting out tests. The history was a total mess. When they finally stopped everything to fix it, it wasn't hours. It was like multiple days of painful debugging just to get back to green.
Wow.
Yeah, it kills momentum, tanks morale, trashes quality. Red build, stop everything. Everyone swarms it. Fix it now. Priority 1, no exceptions.
That story really paints a picture. Letting the pipeline decay is super costly. Okay, so moving from frequency to how the code changes actually get integrated. Branching strategies. Seems like there's a strong preference these days.
Oh, definitely. The old way often was feature branching. You know, create a branch, work on your feature for days, weeks, maybe,
Sounds isolated, safe.
in theory. But the killer problem is delayed integration. The longer that branch lives,
The further it gets from the main code.
and the absolutely nightmarish the merge conflict becomes when you finally try to bring it back. It's like, that analogy, pulling off a huge bandage really, really slowly.
Ouch. Yeah, I get it. More pain, just drawn out. So what's the better way? What do high-performing teams do?
Trunk-based development. Simple concept. Everyone integrates their code into the main branch, the trunk, really frequently.
Multiple times a day, like you said.
Ideally, yeah.
But wait, how do you manage half-finished features then? If everyone's dumping code into the same place, surely you'd break things for users.
That's the key. Feature flags
Yeah.
or feature toggles. They're absolutely crucial for making trunk-based development work smoothly.
How do they help?
You wrap any new or unfinished code in a conditional block controlled by a flag. This flag can be turned on or off externally, maybe through a config file or a dashboard.
I see. So the code gets checked in, integrated, tested by CI.
Exactly. It's in the main code base, getting verified constantly,
Yeah.
but it's hidden from users until you decide to flip the flag on.
So feature flags decouple deploying the code from actually releasing the feature.
Precisely. And this fits perfectly with what the DORA research shows. Year after year, they find that trunk-based development combined with really short-lived branches, like branches that exist for less than a day, and teams having very few active branches at once, is a hallmark of elite performing tech orgs.
That's a powerful point for an interview. What about Git flow then? It's everywhere, but seems like it uses longer branches.
Git flow is common, yeah. Especially in open source, lots of contributors, maybe you don't know them, you need that isolation before they propose a change via pull request. Makes sense there.
But for internal teams?
For typical internal teams, a smaller group, everyone has commit rights. Git flow often brings back that delayed integration pain because of its longer-lived feature and release branches. It optimizes for a different scenario. So, yeah, in an interview, if you start strongly advocating for long feature branches or strict Git flow for a regular company team, it might raise a little red flag.
Suggests you might not fully grasp the benefits of that frequent integration buzz.
Kind of, yeah. Trunk-based with feature flags is generally the preferred answer for speed and stability inside most companies.
Got it. Okay, so trunk-based, feature flags get the code integrated. Now, how does that code journey towards production? That brings us to the build pipeline architecture.
Right, the pipeline is that defined path, check-in to potentially live, and it's usually broken into stages. The key idea, get fast feedback first.
How?
Run the quick tests early. If they pass, then run the slower, more thorough tests. Don't waste time on long tests if the basics are broken.
So, like, unit tests run before the big end-to-end suite?
It's exactly. Group them by speed and scope. Maybe stage 1 is fast tests, unit tests, static analysis, quick checks, runs in minutes. If that's green, trigger stage 2. Slow tests, integration tests, component tests. Maybe faster end-to-end, takes longer. Then maybe stage 3. Performance tests, stage 4. Deploy to a UAT environment for user acceptance. Could be manual or automated. Then finally stage 5. Production deploy.
Balancing speed with confidence at each step.
Precisely.
And the artifact, the thing we built once, way back at the start.
Yes. The very same artifact, the identical binary or package, it moves through every single one of those stages. It gets promoted. Stage 1 passes, promote to stage 2 environment. Stage 2 passes, promote to stage 3. This is absolutely fundamental to that build once, deploy everywhere idea.
You gain more confidence in that specific artifact as it passes each gate.
Exactly.
So having a visual of that pipeline helps track things.
Oh, hugely. You can see, okay, build 120, failed in slow tests. Build 121, got to UAT, failed there. But build 122, sailed through everything, now it's live. Gives you that crucial visibility, traceability.
This whole pipeline idea, it sounds like the core of continuous delivery, CD.
It absolutely is.
Yeah.
CD builds right on top of CI. It means every check-in that gets through all the automated stages of your pipeline is basically a release candidate. It's ready to go to production.
Ready to potentially go. Does CD mean it has to go automatically? Can there be manual steps?
Good question. Yes, CD allows manual steps. That's the key difference from continuous deployment. With continuous delivery, the artifact is proven ready, the whole process is modeled in the pipeline, but you can still have a human gate. Like maybe a product manager does a final UAT check, or there's a button someone has to press for the production deploy.
The pipeline manages the flow, even if parts are manual.
Right. It just shows you where everything is.
Okay, so CD means ready for production, maybe with manual approval. What's continuous deployment then?
Continuous deployment is the next level. If an artifact passes all the automated verification stages, absolutely no manual gates involved, it gets deployed automatically to production. No human intervention needed for the deploy itself.
Ah, okay. So you need CD before you can even think about continuous deployment.
Exactly. You must have that reliable pipeline producing release candidates first. But lots of places stick with CD, with that manual gate, for various reasons, maybe regulations, maybe just risk comfort level. But, the more you automate in your CD pipeline, the closer you get to being able to do continuous deployment, even if you don't enable the final auto-deploy step.
Right. The pipeline pushes the artifact through different environments, test, staging, prod. Seems like there's a big trade-off hiding in there.
The critical one, yeah. It's the constant balancing act between the speed of feedback you get from a pipeline stage and how production-like the environment for that stage is.
Faster feedback usually means less like production.
Generally, yeah. The absolute fastest feedback is running tests on your laptop, right? But that's nothing like your production setup.
And the other extreme, deploying every commit to a full production replica.
Super high confidence, but incredibly slow and probably wildly expensive, especially at scale. So pipeline design is all about finding that sweet spot. Early stages optimize for speed, maybe use mocks, stubs, lighter environments. Later stages prioritize fidelity, closer replicas of production, even if they take longer to run and test in. Getting that balance right is key. Interviewers love asking about this trade-off.
And this brings us back again to that build once, deploy everywhere artifact rule. Feels like the linchpin for managing environments.
It's the absolute bedrock. Immutable artifacts. That's the goal. Build it once, stick in your artifact repo, and that exact artifact gets promoted. Test end, staging, UAT, prod. Same binary.
Stops those, well, it worked in staging. Nightmares.
Exactly, because the code itself isn't changing between environments.
But environments do need different settings, right?
Yeah.
Database URLs, API keys, log levels. How does that work if the artifact is immutable?
Right. Because the artifact must be the same. It also has to be environment agnostic, all that stuff that changes per environment. Database strings, secrets, feature flag settings. It must live outside the artifact. Externalized configuration.
Ah, like giving the same car different GPS coordinates depending on the destination city.
Exactly like that. Perfect analogy. The car, your artifact, is the constant, reliable thing. The map or coordinates your external config tells it how to behave in this specific place, this environment. You inject that config at deployment time.
And the interview red flag here.
Oh, rebuilding the artifact for each environment. Or worse, baking configuration like database passwords inside the artifact itself. Huge no-nos. Shows a lack of understanding of immutability and security. You want immutable artifact plus external config, period.
Makes total sense for building reliable systems. Okay, we've mentioned tools like Jenkins, Circle CI, Travis throughout. How do they fit into this whole CD pipeline picture now?
Well, the tools are crucial enablers, right? They support the practices. Ideally, you pick tools built with CD in mind. Tools that let you easily define these multi-stage pipelines, visualize them, manage promotions, handle manual approval gates cleanly.
So not just a CI tool that only builds and tests.
You can sometimes bend older CI tools to manage CD pipelines, but honestly, it often gets really clunky. Trying to script complex environment management and promotion logic in something not designed for it can be painful. Better to use tools designed for modeling the whole release flow.
It's about using the tool to model the entire path to production.
Yes, not just the first step.
Okay, this has been super helpful. Really clarified the concepts, the anti-patterns, the why. Let's switch gears slightly. Let's do a quick simulation. How might these ideas pop up in a senior system design interview? I'll throw a question at you.
All right, yeah, hit me. I'm ready.
Okay, scenario 1, design question. You need to architect a CI/CD pipeline system for a new microservices platform. Could be, say, 100 plus services eventually, goals, fast feedback for devs, high confidence for prod deploys. Where do you start?
Okay, 100 plus services. Scale and speed are paramount. First, probably clarify some things. Deployment target, Kubernetes, serverless, team setup, monorepo versus polyrepo. But assuming some defaults, the core principles still apply. Frequent integration, build once, external config. The big challenge with 100+ services is parallelization.
How so?
You can't have everything run sequentially. Each service probably needs its own pipeline definition, and the CI system needs tons of build agents to run builds and tests for many services concurrently. Otherwise, devs wait forever for feedback.
Makes sense. What about dependencies? How do you handle integration testing when service A depends on service B?
Yeah, that's the tricky part at scale. Pure independence is nice, but often unrealistic. One way is dedicated integration environments, but they get complex and slow to spin up and manage for 100+ services. A more modern pattern is consumer-driven contracts.
Explain that quickly.
Basically, service B, the consumer, defines how it expects service A, the provider, to behave. Service A runs those contract tests as part of its own pipeline. If service A breaks the contract, its pipeline fails before it affects service B, reduces the need for big, slow integration environments.
Interesting. And artifacts?
Central artifact repositories are vital, clear versioning, rock-solid rollback mechanisms too, because with that many services, something will go wrong in prod eventually. Fast, automated rollback needs to be part of the design.
Good points. Parallelization, contracts, rollbacks. Okay, next question. More implementation style. Your team, maybe 15 engineers, is stuck using long feature branches. Merges are painful. You want to move them to trunk-based development with feature flags. How do you actually do that technically and culturally?
Oof, yeah, that's a common transition. It needs patience. Technically, step one is getting a feature flag system in place. Either build a simple one or integrate a service like LaunchDarkly or similar. Then, engineers have to learn the discipline. Wrap all new significant work in a flag right from the start.
How do you introduce that change? Big bang?
No, definitely not. Start small. Pick one, maybe two, new features that are reasonably self-contained. Develop those only using flags on the trunk. Let the team see it work, feel the benefits of no merge hell.
So pilot project.
Exactly. Then expand. You need clear team standards, how flags are named, managed per environment, tested, and importantly, cleaned up afterwards. Don't leave dead flags littering the code. Culturally, it's about constant communication. Explain the why less merge pain, faster flow, quicker feedback. Code reviews become critical enforcement points. Hey, this new endpoint isn't behind a flag, needs one before merge. Maybe gradually tighten branch lifetime rules too, from weeks down to days, then hours for most things.
Right, technical steps, plus that cultural shift. Okay, last one. Debugging. Process scenario, you're on call. Critical service pipeline, red. Been red for 3 days solid. Teams are finding workarounds, deploying old versions manually, commenting on the tests, just to merge code. What do you do right now, and what long-term changes do you push for?
Okay, 3 days red. Alarm bells. Immediate action. Stop the bleeding. Freeze commits to that service's main branch immediately. Nothing new goes in except the fix. Find out which commit broke it. The CI tool history should show this. Get the team, or a key subgroup, together now. Fixing the build is priority 0. All hands on deck. Swarm it.
How do you tackle the fix?
Divide and conquer. Is it flaky test? Bad code merge? An environment issue? Roll back the main branch to the last known good commit if you have to, just to get green, then figure out the root cause on a separate branch. Get the pipeline green again, ASAP.
And the longer-term fix for the process that allowed this?
Yeah, this situation signals a major breakdown in discipline. You need to dig into why. Why did teams feel they had to bypass the broken build? Deadline pressure. Did they not understand the downstream consequences? You need to reinforce hard that broken build stops the line principle. Technically, maybe configure the CI tool to physically prevent merging to a red main branch. Culturally, push for collective ownership. The pipeline isn't someone else's problem, it's everyone's. Maybe daily stand-ups explicitly check build status and run blameless postmortems on these failures. What can we improve in our process, tooling, or habits to prevent this? Focus on learning, not blaming.
Wow, strong answer. Hitting the immediate fix and the crucial cultural repair, that's definitely showing senior level thinking. Understanding the system includes the people and process.
Yeah, exactly. It's not just about code, it's about how the team works together to deliver reliably.
We have covered so much ground. The CI, CD, continuous deployment differences, the huge importance of frequent integration, trunk-based, feature flags, multi-stage pipelines, balancing speed and confidence, that golden rule. Build once, deploy everywhere, external config, why fixing red builds is non-negotiable, and how these concepts play out in interviews.
Yeah, getting your head around these ideas, the why, the trade-offs, being able to spot those anti-patterns, that's what gives you confidence in those system design interviews. And honestly, it just makes you a better engineer, helps build better software day to day.
So as you're thinking about your own systems or prepping for that interview, here's a final thought to chew on. That trade-off, speed versus production likeness in your pipeline. How much production likeness do you really need early on for fast feedback? And where could something like, say, testing in production fit into that whole picture for your specific services?
Yeah. That's a really nuanced question. Depends a lot on context.
Definitely something to ponder. We really hope this deep dive gave you some solid frameworks and boosted your confidence. If you've got your own CI/CD war stories or maybe interview questions you've faced, share them in the comments. We'd love to hear them.
Yeah, absolutely.
And if you found this useful, please do like and subscribe. We'll be back with more deep dives into the tech concepts that matter.